Good morning, students. In previous class, we have studied about pulse width modulation, how to glow an LED light through pulse width modulation at an intervals of 0, 25%, 50%, 75%, and 100% respectively. Now, let us say I don't want increment in 25%. I want it should start from 0, 1%, 2%, 3%, and it will go up to 100%. That means at all levels, LED should glow. So if you go by normal programming, as we have seen in the previous lecture, it will be very cumbersome and very lengthy. So we have to use something which is easier than the previous method. So there comes the concept of for loop. So now we will study today, in today's class, we will study how to use pulse width modulation with for loop. So let us start. Again, as I said, there will be only 3 steps. First step is initialization of pin. So I will declare the pin. So let us say again I am using the same LED 1 is equal to 9. That is first pin. That is LED 1 I will be using on pin number 9. And as I told, we can use only the pins available with pulse width modulation. So you can use only of pin number 9, 10, 11, or you can use 4, 5, 6. Sorry, 3, 5, 6. Wherever you will see this sign of pulse width modulation like this, this kind of sign indicates pulse width modulation. And if you want pulse width modulation to get activated, you have to connect on this particular pins. Now, second step is you have to, in void setup, you have to write the pin which you have declared will be used as output pin or input pin. So because as it is LED, it will be an output. So I will write pin mode 9, output. So this is over. We'll close the bracket. And the third part, finally, is the void loop, which is going as per logical sequence. So now let us see what is the logical sequence which you are going to follow. Our LED should be off for first time. Then it will go for 1. It should go for 2%, 3%, 4%, 5, and so on. And it should now brighten by 100%. So this sequence should be followed. If we go by normal procedure, it will be a very cumbersome task to write the program. And it will be also a lengthy program. So today we will be using the for loop. Now how to use the for loop? So you know that for a for loop, the syntax is something like this. You write for, then here we write initial condition. Initial, then we have to check the condition which we want. So here the condition is coming, and then what should be the operation? Increment, decrement, and so on. So this is a syntax for loop. So let us start with that. So now I will write here for int I is equal to 1, for int I is equal to 0. Here we are starting from 0, initial condition. Our LED should be not glowing at the initial start. Then next condition, the check condition is till I is less than or equal to 255. So it will start from 0. It will start from 0 and it will go up to 255 at the increment of 1, I plus plus. So I plus plus means increment of 1. So from 0 it will go to 1, then 1 to 2, 1, 2 to 3, 3 to 4, and so on. And finally it will reach 255. Now what to do if this condition is satisfied? If this condition is satisfied, what to do? We have to write analog write LED 1, I. Now just see from this what will happen. Let us see. Int I is equal to 0. So now I value is 0. So it will be analog write LED 1, 0. Correct? So LED will not glow. Then what will happen is it will check the condition. I is equal to 0, I equal to 1 because it has been incremented. So now I value is 1. Okay, it is less than, I value is 1 now. It is less than 255. So again it will increment. So it will be 2 and it will go to next step. Analog write LED 1, I. Now I value is 1. Again the for loop will start. I is equal to, now value is 2. It is less than 255. So it will first take the increment. So it will make this as 3. Going to next step, analog write LED 1, I. So now I value is 2. And so on. So this is how for loop works. Now we need delay also. So I will write delay for 500 microseconds, that is half a second, and then I will close the for loop. This entire for loop is working only for LED glowing. So if the program is just write a program to glow the LED in steps of pulse width modulation from 0 to 255, this is the program. This will end your program. But if I say I want to glow the LED in steps of 1 increment and also of the LED incremental steps of or decremental steps of 1. So one more loop will come. So I will write one more for loops. I will write here for j is equal to 255. So now here you can see my starting point is 255. So I am taking new variable j because I have already used I here. So int j should start from 255 and it should go up to 0. What we have written here in the first step, start from 0, go to 255. Here I am writing start from 255 and go up to 0, 0 and decrement in the steps of 1, j minus minus. So first it will be 255, then it will come to 254, then 253, then 252 and so on, it will go to 0. And till this condition is active, what we have to do, we have to write here analog write LED 1 comma j. Whatever j value will come, it will take from here, and in that particular voltage or at that particular condition, the LED will glow at that particular volts. Then I will write delay 500, that is half a second delay, and then program is over. So this entire loop, the second one, this loop is used to making the LED off in a steps of 1 in a step of 1 decrement. So I hope you have understood the program. Now let us go to the TinkerCAD, that is simulation part. Okay. So again I have taken an Arduino, an LED which is connected to pin number 9, and other pin connected to ground. Same connection is there. Just I have to change the code. So now here I will just copy paste the code which we have just seen. So I have copy pasted it, and then I will start the simulation. So here you can see the light is glowing on. Closely if you observe, the light is glowing on in the steps. If you observe, the intensity is increased. Now this is at the peak value. So full brightness now, and then similarly it will go in the off state. So this completes the simulation of this particular circuit, that is pulse width modulation at each and every step. So hope you have understood the program. If you have any doubts, you can contact me. Thank you.